Alright, this video is over elements and compounds, but the first thing we're going to do is recap the different types of matter that we looked at so far, and then we're going to look at where these new elements and compounds fit in with the rest of what we've seen before. So we're going to start out with kind of like a flow chart. Alright, we have matter at the top, and matter can be divided up into one of two different ways. Okay, you either have a mixture or you have a pure substance. And we have pretty much focused on the mixture side. And so when we look at mixtures, if we remember back, there are two types of mixtures. We either have heterogeneous mixtures or we have homogeneous mixtures. Okay? And then we looked at even further as to heterogeneous mixtures. We split up into two types that we looked at. And the one type we looked at was a suspension. And another type we looked at was a colloid. Now, it doesn't mean that heterogeneous mixtures have to be one or the other. It just means those are some types that we looked at. Okay, and we looked at an example of some homogeneous mixtures, which were solutions. So again, not every single homogeneous mixture is a solution, but that's just the one type that we looked at. So that's kind of a recap of what we've been doing. We're now going to focus a little more on this pure substance side and elements and compounds. So let's start off with, first off, elements. What exactly are elements? Okay, elements are something that cannot be broken down into a simpler substance. And there are lots of different examples of elements, and we'll look more closely at these in the next chapter. But for example, you have any element on the periodic table is an element. So we've got things like oxygen, carbon, hydrogen. Okay, those kinds of things are all elements. You cannot break them down anymore into anything any simpler. Okay, compounds then are combinations of two or more elements. So we're going to have things like carbon and oxygen together, or hydrogen and oxygen together. And we're going to talk more about compounds in the next video for the chapter dealing with the laws of definite and multiple proportions. But from right now, just got to know that there are different combinations of elements together. So how are compounds related to elements? So how are compounds related to elements? Well, the properties differ from elements, or the elements that combine them. Okay, hydrogen and oxygen apart do not have the same properties as when they are together, and when they're together in different amounts, they have even more different properties. But they're just combinations of the elements again. So that's really how they relate to elements. Now, the next question is, what makes a compound different from a mixture? Because they sound like very similar things. They are combinations of things. Well, it's what they're combinations of that makes them different. Okay, a compound, like I just said, is two or more elements, whereas a mixture, okay, is two or more pure substances. And the pure substances can be elements or compounds. You've got combinations of different substances together in one thing. I don't just have hydrogen and oxygen together to make a compound. I've got water and salt and sand and sugar and sulfur and all kinds of different things together. That would be a mixture. Okay. Looking at a compound, okay, compounds have to be separated by chemical means, not physical means, whereas mixtures can be separated by physical means. Alright, so if we were back up to this at the beginning, your pure substance would break down into either an element or a compound as the types that we're going to look at, or types of pure substances. Now we're going to look at different types of elements on the periodic table, and this is just kind of our introduction to the periodic table. We'll look more closely at the elements in the next chapter and even more closely at it in the following chapters. So let's just start off with metals. Okay, some properties of metals. They are good conductors of heat and electricity. Most of them are solids at room temperature. They tend to be what we call ductile, which means they can be drawn into a wire. And they tend to be malleable, which means that they can be hammered or molded into sheets. Okay, so you've got plenty of examples here. You've got things like iron, copper, aluminum, nickel, cobalt. Those are all solids at room temperature. They're all very good conductors, and they can be pretty much drawn into a wire or hammered around or molded around. Okay, you do have the occasional metal that is actually a liquid, and our main one with that one is mercury. And then you have other metals, which are what we call synthetic, which are kind of like man-made things. Those tend to be the bottom of the periodic table. So let's look at some properties of nonmetals now. Okay, nonmetals are kind of the opposite of metals. They are poor conductors of heat and electricity. They tend to be gases at room temperature. And so we don't have things like they're not ductile and they're not malleable because they're not solids. Nonmetals, you've got pretty much the right side of the periodic table. We've got things like hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, okay, things like that. And the last type of element we have are what we call a metalloid. Okay, metalloids are in between a metal and a nonmetal. And these tend to be what we call semiconductors, meaning again they're somewhere in between. They are less malleable than metals and more brittle than nonmetals. And most metalloids are solids. Alright, with the periodic table you have groups and you have periods. Okay, groups, or sometimes they're called families, are the columns on the periodic table, and the periods are the rows. If we take, for example, this periodic table, and we're just going to look at the groups and the periods here to try and figure out, based on these practice problems, which elements are located where. So if we look here at the practice one, it says in group 13, period 3. So groups, again, are the columns. So we're 13 columns over, which means we're here in this column with boron. And we are in period 3, so we're the third row down. Now you gotta be careful, it's not the third one in as in Ga, gallium, because gallium is actually in the 4th row. We're looking at aluminum, which is in the 3rd row, because hydrogen and helium are their own rows. So be careful when you're counting. So Al is the answer there for group 13, period 3. If you're looking at group 2, period 5, okay, that means again I'm going to the 2nd group here, and 5th row down. So I'm looking at Sr, strontium. We go to group 18, period 6. We're going to go all the way to the right. Okay, and go down to the 6th one. And we are looking at Rn, which is radon. Finally, I'm looking at group 1, period 7. So I'm going all the way over to the 1st group and all the way down to the 7th row, which is Fr and francium. Okay, so now we're going to look a little more closely at our periodic table as to what's a metal, a nonmetal, and metalloid, and how to read it. Okay, so for these examples, then we can figure out what things are. Well, this table goes into a little more depth than we need. Okay, but everything to the left of these light green ones, which are metalloids, notice how that's highlighted there in the middle of the page. Okay, those are metals. So all of the orange, the yellow, the kind of purpley colors in the middle, notice how they say metals, okay? That is all of these colors. So notice how it's the post-transition, transition, lanthanoid, actinoid, alkaline, alkali. We'll get into those later. But metals are all the ones that are highlighted there, okay? Notice how they kind of take that jagged line there on the right? Well, that's our line, our stopping line. Everything to the left is a metal, okay? If I go non-metals now, everything to the upper right. Notice how many less these metals are, or non-metals are. Okay, there's very, very few of them, and most of them, other than bromine, are gases. Then we've got metalloids on the line there, okay? And if you look at your periodic table that I gave you, there's actually a jagged line there, okay? And these are the 7 that are actually metalloids. Okay, aluminum there, Al, is a metal, not a metalloid. So what you want to do is kind of mark on that periodic table that I gave you where the metals are, where the nonmetals are, and where the metalloids are. So there are my metalloids. Make sure you mark those, so pause and mark it. You've got your metals, everything to the left of those jagged lines. Don't include hydrogen up in the upper left-hand corner, Okay, leave hydrogen alone. Hydrogen is a nonmetal. Now I got all my nonmetal, which is everything to the right, and hydrogen. Okay, so make sure you mark your table so you know which parts are what. Okay, now going with that, look at these practice problems. Okay, I've got sodium, which is Na. Sodium is over here. It is a metal. Left side of the table. Argon, all the way to the right, okay, is a nonmetal. Silicon lies in the middle. It's on a jagged line. It's just not on this particular periodic table. That is a metalloid. Sulfur, all the way to the right. That is a nonmetal. Fluorine, again, all the way to the right. That is a nonmetal. And then I've got cesium, which is Cs. And that's all the way to the left, and that is a metal. For this chapter, you don't necessarily have to know the symbol and the name. I'm just getting you acquainted with it. But you will have to look on the table and tell me, is that a nonmetal, a metal, or a metalloid?